Hi everyone. In this lesson we will talk about the OpenCV, open source computer vision library, and we gonna talk about it, and we will learn how we handle this tool in order to capture the pictures or the images or the matrix to manipulate in Python programming language. Okay, and so firstly I create the week 10.1 take image.py. This is the first example of our session. We take the image and represent the show and display this tool in here. Okay, so firstly we need to give some basic information about the OpenCV library. In that case, OpenCV library. Okay, and so this is end. And so what is the OpenCV? OpenCV is a popular library for computer vision, okay, and image processing in Python or any other language. In C or C++, we can develop this OpenCV. In the first place, the OpenCV was developed for the C++ by the Intel, but in the next lectures we will implement this code in Python or Java or any other programming language. Okay, it provides the various functions and tools to work with image and video. Okay, and so in order to learn this tool, we need to study about firstly the image representation. Okay, what's the image representation? Image representation means that we create the matrix to store to the image formats. As you know, the image is contained with the R and G and B values, which means that we have 3 values in here, and then we're gonna store to the 4D matrix or the 3D matrix in order to represent the correct image representations. Okay, after that we will learn to reading and displaying image in our computers or in our systems. Okay, and after that we can build the image operations, for example the cropping, resizing, rotating or flipping. We will learn about the color spaces in this domain: RGB, BGR, blue, green, red, and HSV, and grayscale format. Okay, and after that we will learn about the image filtering, for example the H detection using the canny filter or something else. In this phase we're gonna create the contours and shape detection by using the machine learning or any other algorithms in here, and we will learn about the histogram for image enhancement. Okay, morphological analysis, for example we can apply the erosion or dilation to the image, and object or face detection is learned in here. Okay, this is the basic topics we will process in this lesson. Okay, firstly I need to give the example 1 in here, like this one. We will import the CV2 library. Firstly, this is the OpenCV library for the Python extension. Okay, and so if you don't have any OpenCV library, and then you must install the pip install Python OpenCV. Okay, and so in the internet you must learn about how you can install this library. Okay, I don't remember what's the correct phrase in here, but you can get the internet to install this library. Okay, and so CV2 has a init.py function in here like this one, and then we can use the every function and every installed library in the in CV2. Okay, and also we will add the import matplotlib .pyplot library to visualize the whole data in here like this one. In this case we have the JPEG image in here, Detaylı. Okay, and so we install or download this picture in here and represents the whole this JPEG format image into the into the matrix domain. Okay, and so if we convert the every JPEG image or data to the matrix, and then we can show this picture by using the CV2 or the OpenCV library. Okay, and firstly we need to give the image path in here like this one, Detaylı JPEG. Okay, and after that the image can be created with the image inbreed function. Okay, for a given image path. Okay, this is how we can use to this notation. And so if I run this code, we will have specific matrices like this one. For example, 155, 158, 156. This represents the RGB code for the for this picture. Okay, and so if we take this resolution of the Detaylı in here, for example, 640 times 320, and then we will have this matrix in the resolution of the 330 and times 640. Okay, and so we will have this notation, or we can print the image size or shape in here. This is the property of our code in here like this one, and so we will have the 4000 blah blah blah, 3000 blah blah, and we have the 3 RGB code, and so this is the 3-dimensional matrix. Okay, so we need to check in the first place like this one, the image is none, which means that the image does not represent anything, or we will not get the total representation of this image, or this image is absent, and then we need to give the printf error unable to load the image at, I'm sorry, about that, I have a package, and so we need to give the correct representation, but unable to load the image at the image path. Okay, if this is the case, but if not, and then we have the image matrix in here. Firstly, I can show you the desired width, for example 60, and desired height 600, and then we resize the image to the specific format. In the image processing application, we highly utilize this resizing operation, because resized image CV2 resize has a function in here like this one, the image, and we need to give the tuple values in here, width and height. Okay, and so we convert the whole image into the one notation, or the generalized notation, especially for the resolution of these things. Okay, And so this resized operation gives us to the what, to the resized image shape must be given at this case with the what, with this notation. And so in the first place we have the 4000 and 3003 three-dimensional matrix, but in the second place we have the 603 RGB code in here. Okay, especially for the machine learning application we have the resize operation for the what, for standard sites hold the image into the one domain. Okay, so how can we show this image in our computer? We have the imshow function in here, and so we need to give the some title to this resized image like this one, and then we can show these terms. Okay, but we need to give the wait key function in here like this one. This is to what, the wait for a key press before closing window. Okay, and so until we push the button or key, and so we have this imshow function or the imshow body. Okay, and after that we need to destroy all the windows because we have a dynamic memory in here, especially for the OpenCV application, and then we need to give or return to the what to hold allocated space to the computers. Okay, and also alternatively we can use the what, the plot imshow function in here, because the matplotlib also have the imshow body like this one, but we need to give the CVT color in here like this one, for example the resized image, and we can turn to the what, the color BGR, blue green red to RGB. Okay, and also we can give the what, the PLT title in here, resized image. This is the identical process, but we can utilize this body. Okay, axis off and PLT show. Okay, so if I run this code, and then we will have this notation, resized image. This is the output of the what, the OpenCV library. Okay, but if I push these Q values, and then this figure also represents to the what, to our PLT function or the image, because this image is represented by the matrix notation or the numbers, and then we will show this image, or we can show this image especially both in the way for the what using the matplotlib or the OpenCV library. Okay, this is how we can handle to what, to our codes. Okay, can you see the screen right now? Feyzullah? Okay, so this is the first example of the what of taking image from the file or folder. Okay, if we change this notation in here, and then we will have the different image. Okay, so in the second place we can create another example in here like this one. Take cam pick example. Okay, what is the meaning of this? It's the meaning of the what this example is related to what, the taking image from computer camera. Okay, firstly, in order to connect our computer camera, we need to import the what, the CV2 in here like this one, and cap should be assigned with what, the CV2, and video capture we have this function in here with the 0 values. Okay, and so this function is represented to what, is a class of CV2. But how we can handle this video capture? This video capture connects the our camera and taking the specific matrices or the images from the our own computer camera, or you can utilize the another external camera by using to obtain any image from the external world. Okay, and so but this is the basic condition or the basic function to connect the our camera using the OpenCV tool. Okay, and so firstly we need to implement this cap operation in here, because this class operation in here like this one, and so we need to control to is opened function. Okay, which means that it's returned to the we connect the camera or not. Okay, and so if this is the case not opened, and then we need to give that the error couldn't open camera. Okay, but this is not the case in this case, and so we easily connect the camera or our own camera, and after that we have the some specific function for the capture a frame from the camera. Okay, for example, we have the cap.read function. This read function taking the image from the camera or taking the matrix from the camera at each case, and then returns to the our read and frame work. Okay, and so this frame contains to the our resolution or our camera matrix. Okay, and so we can print the frame shape. Okay, in this case we will have this notation. Okay, and so we can also give the another condition in here, red. The red is directly a boolean value to checking if the frame is captured successfully or not. Okay, if the frame is successfully captured and this is not the case, and so we need to give the error could not read the frame. Okay, it's important to add this protection code, because if we don't have any image, and so we can collapse the whole program. Okay, but this is not the case, and else we need to give the CV2 im show in here with the title of the camera image, and we need to give the frame at the im show function, especially for the in this case if we check the whole notation in here like this one, this red returns the boolean value of is camera ready or not, and this print frame is is our resolution for taking the picture from our computer camera. Okay, and so if this is the case, we can create the CV2 wait key function in here for pressing the button to close everything in our cases, and after that we should give the release function or call the release function in here, because we have the allocated space in here for the video capture. We need to give this space to the computer or the RAM. Okay, and also we need to give the CV2 destroy all windows. Okay, because we reached some operating system function, and so we need to tell the computer or the program to our mission is end. Okay, and so if this is the case, and then we will show the image, and so this is my picture in here creating lesson, but just look at that. This is the 480 and 640. These are the resolution, and the three values is the RGB codes, red, green and blue. Okay, and so if I push the any button in here, and then I will take to the end of this code. But how can we take picture and write or create some another JPEG file or PNG file in here? We will have also a CV2 imWrite function to what? Transfer all the matrix or the data into the what? Into the another file or the preserving file, like the detaylı.jpg file. Okay, we can save any file in here. For example, the captured image.jpg. This is the file name to be created in our system, and we should give the what? The frame matrix in here, like this one. Okay, so if I run this code, and then this is my picture, but I can push this time, and so just look at that, the captured image JPEG file is created in here. Okay, and so if I take this picture, and then this is saved in the what? In OpenCV folder. Okay, and so this is how we can save the image by using the OpenCV and show or store this JPEG into the what? Into the our system. Okay, so any question? Okay, in the third case, we should give or create the video by using the OpenCV library. Okay, for the creating the library, we will same notation in here. Firstly, we should give the head title in here, like this one, the X creating video using OpenCV2. Okay, and so firstly we need to import the CV2 like this one, and so we need to create the some class instance. It's related to what? The CV2 video capture class in here, like this one, and so this video capture correctly create the instance and assigns to the what? The cap, and so we can create or read or display any data coming from the what? Our own computer camera. Okay, firstly, just before we created the not cap is opened. Function should be controlled if this is the case, and we should give the error could not open camera. Okay, but this is not the case, and then we need to give the what? The some video writer function or the correction in this case. For example, we have CV2 video writer for CC object in here with the definition of the what? The argument parameter in here xvid. This is the what? The codec of the camera. Okay, and so we can create this function body in here, and then this is the type of the codec. And so you may not know this function or body in here. It's a detailed information about OpenCV, but if you want to save or store any video or creating the video, you must use this syntax. Okay, and so after that we should give the what? These terms for CC in here, like this one. The out can be created with the what? The video writer. The writer function, video writer function used to do what? To create any image or the videos in our system. For example, the captured video AVI file in here is the type of the what? The R video, and for CC should be given in here, and this is the frame rate for the what? FPS in here, like this one, and frame size should be given, for example, 640 and 480. Okay, this is the total representation of the what? Setting the camera properties. Okay, and so if I want to this code, and if I run this code, and then this codec is implemented in here, like this one, and so we should use the what? Video writer to with the properties of the 4cc codec type, frame rate, and the what? The resolution of the our image. Okay, this is the adjustment of the what? Resolution and frame rate. Okay, we can change this parameter, but you should know that if your camera provides the up to 30 FPS, we cannot use the 60 frame rate in here. Okay, just remember that this is a dependent process for the for both the physical device and your computer and also your programs. Okay, and so if this is the case, we should give the while true or endless loop in here, because if you want to take or create the video, and then we should continuously give or take the image from our camera. Okay, and so firstly, as always we do, the red is the Boolean type of the camera frame rate. Okay, and so cap read must be calling in here, and if the red is true, and we will have the specific or the correct frame rate or the frame from our computer camera. Okay, and so if not red, and this means that we cannot take the frame in here, print error could not read frame. Okay, we should give that, and after that we should give the break, because we need to break the loop, endless loop in here, because we don't have any frame, and so this is the collapsed case for for our program. But this is not the case, and so we should give the CV2 im show in here, like this one, camera video, and we should give the frame at each case, because at each case we read the camera information or the matrix in here, and after that we will provide to the frame into the im show functions. Okay, and after that the out, this is the video writer process, and we should write the each frame in here to build the camera applications. And so in each case we provide or feed each frame taking from the camera and transfer to the out CV2 video writer. And so this out at each case appends the whole image after that, and so we have the 20 frame rate or resolutions in here, and so in each seconds we feed the 20 frame to this out, and we store the whole data. And after that if CV2 wait key should be given in here, like this one, or 0xff is equal to the ort Q, which means that if I push the Q or quit button, and we can break this process. Okay, after that we need to give the cap, we should release this function, and also out releases. Okay, and also we need to give the destroy all windows for terminate to the OpenCV process. Okay, and so if I run this code, and then we will have this image. Okay, you can see my face in here, like this one, and so if I push Q, and then like this one, we have the captured video away. Okay, and so this is stored in the in file operation, and if I run like this one, see that this is how we're gonna handle the whole process in OpenCV application. And so we can create the videos with specific frames, and we can analyze or store any data through this video framework. For example, in your application you can build your own videos by using these terms, especially for the machine learning application or the mathematical signal processing analysis. We can increase or the turns to to this process in order to set a different property your image. For example, in the next case we will talk about it. We will condition the image to getting the proper way to be what? To be analyzed in your program or in your algorithm or in your mechatronic applications. Okay? Any question? Okay. If there is no question, we should continue with the week 10.4 examples size filter application. We can utilize the sum filters by using the OpenCV on the on the videos or the images. Okay, we can condition the whole data by using these terms in that case. Okay, firstly we should give the title of our algorithm in here, X some filtering operation on video or the image. Okay, so import CV2 must be included in here, and cap also should be created with the video capture. Okay, this is the initialization constructor for the for reading the image from the camera. Okay, and so as always we do, we need to give some basic condition in here. Cap is opened like this one, and so we can print the error could not open camera. Okay, but this is not the case, and after that we should give these terms. Firstly, we need to give the while true, while true like this one, and also we can print the filtering operation is started. This is the basic information for for the user, for example, in this case. And so firstly, as always we do, we need to give the red and frame tuple values, and we fill these values with the cap.read function. Okay, and so each image capturing from the camera is transferred into the frame, and with the correct values or the boolean values of the if this is okay or not. Okay, if not red, and so we can say that the print error could not read frame. Okay, and also we should give the break in here. Firstly, how can we apply the sum transformation or the filtering operation at this case? Firstly, we need to give the height and width value and unused value for the frame shape. Frame shape returns to returns to dimensions of our picture or the image. Okay, for example 460, 640 and 3. Okay, height is equal to the 460, width is equal to the 640, and 3 unused, and so this variable is is an ordinary values or the unused values. We can represent the whole things. And so how can we crop this image? Cropping operation in this image formats. Firstly, we need to give some other values with the frame, and so this frame is a matrix, and then we can reach any data by using the open and closes parentheses, because it's just like a numpy array or some list values, but with the multiple 3D dimensional matrix in here or 3D dimensional list in here. And so if we want to cropping the frame, we should give the height divided by 4. Okay, and we need to convert to integer value, because the height maybe cannot be divided by the 4 without remainder. Okay, and so we need to give another upper values in here, like this one, 3 height divided by 4. Okay, and also this is the raw values of our process. For example, this is maybe equal to 100, this is equal to 300 or 400. I don't know, but this is the boundary condition of the raw values, because we cropping the image to the to create the new framework. Just like this information, we can give the white values, okay, like this one. So if this is the case, and then this is the cropping operation like this one, and so CV2 im show, we should show the original picture in here, and we should give the frame at this case. But CV2 im show can also be called with the ROI values and ROI. Okay, this is the cropped image. Okay, cropped image. And so if this is the case, this is the showing pictures or the images on computer, and then we should give the if CV2 weight key 1, and we should give the 0xFF is equal to the ordinary Q. Okay, until we have pushed the Q button, and then this loop is breaked. Okay, and also we need to give the cap release for dynamic memory, and CV2 destroy all windows. Okay, so if I run this code just like this one, for example, we have the total image in here, but we have also to this picture like this one. This is the cropped image. Okay, or we can change the height of these values like this one 2, and width of these values 2, and so if I rerun this code, and so this cropped image turns into into this frame. Okay, and so I can change my position, but this resize operation gives us to the cropped image. Okay, so this is the first example of the filtering operation in in our system. Okay, so how about the other operation? We can resize the frame in here. How can we do that? Resized frame is equal to the CV resize frame, for example 320 and 240. Okay, and after that we can create another CV2 im show function like this one, resized, and we should give the resized frame. Okay, and so if I rerun this code I'm sorry, this must be lower value. It's 1. Okay, and so the cropped image which is given in here, resized image which is given here, just like that, we preserve the whole notation in here like this one. This is the highest picture in here, but we have identical resized, or we small the whole resolution into the one picture. But in the cropped image we crop the picture. For example, we have no microphone in here, but we have microphone in the resized image. This is the basic difference between the resized and the cropped image. Okay, just remember that. Or we can rotate to to our framework like this one. Rotation in image. For this image we need to create the new matrix to rotate the RGB codes, for example at the degrees of 45. or another else. Okay, and so we have the get rotation matrix to the function body in here, this which returns to the what the whole the set values of the proper matrix notation for a given to the what the width divided by 2 and height divided by 2 with the 41 scale and 1 values. Okay, and so this is the degree values and this is the scale values. Okay, and we can set the whole the terms in here like this one, and so the rotated frame can be created in here like this one, CV2 warp affine. This is a function to what create the new matrices in here, but with what frame rotation matrix with the dimensions of the what width and height. Okay, and so this rotation matrix is multiplied with the what with the frame and generate to the what the width and height values at the what at the rotation formations. Okay, and so how can we show these terms in here like this one? The im show is the what the rotated, and we should give the rotated frame in here like this one. And so if I run this code and then I have the rotated image in here, just look at that. Okay, these are the basic formation for the what for rotation. For example, if I change this code in here like this one, the 60 values, and if we rerun this code, and this is the 60 values. Okay, or we can increase or decrease these values by using the what the sum counter. For example, if we have the define the counter values in here like this one, 0 values. Okay, and so in each iteration we can assign to the what the if counter greater than 100, for example, or 500, for example, the rotation frame and rotation matrix is assigned with what with these terms. Okay, just like this one counter, and we can apply the counter plus 1. Okay, or else if theorem, if counter divided by 25. Okay, and so can assign these terms like this one. This is the 20, for example, or 75. Okay, this is the what the 40, 60, and also it's greater than these terms. And so if counter is greater than 0, and after that or 0 equal values in here like this one, and this is the what 20, 40, 60, and 80. Okay, or we can scale this function like this one, 3 and 4 values in here. After that we should check the what the if counter greater than 100, we can assign the counter is equal to 0. Okay, and so if I run this code, just look that. I'm sorry. This is the case of the what and counter 25 and counter 50 and counter 75. Okay, if the greater than 75, and so we should apply these terms. See that? It's the horror movie like. Okay. Okay. And so let's take a break, and then we will, after the break, we will continue with the filters. Okay.